It's a red Goliath star, expecting you put it where the sun is, it would loosen up to the circle of Jupiter. It's enormous, completely sensitive, and going to explode. These impacts are among the most noteworthy ejections of radio energy in the entire universe, delivering more energy than a billion suns. Are you prepared for what will happen? Frightening little animal juice, a colossal red, very beast star, and one of the closest stars to Earth, has actually gone through a striking decrease that has gotten attention. Mixed sentiments overall, this decrease has led to speculation among stargazers and the general public about its potential repercussions. A couple of analysts believe the bizarre behavior could be a harbinger of an inestimable blast, a horrendous event that happens when a star incapacitates its nuclear fuel and collapses under its own weight, provoking a colossal impact. Such an event raises concerns, not just among established scientists, but also among the general population, as it raises questions about the potential impact on our own planet. Bug juice is a recognizable part of the radiant body, or which is easily identifiable in the night sky due to its unmistakable shape and bright stars. Also referred to as Alpha Orionis, it holds the title of the most brilliant and biggest star in this sublime body. Continuous data assembled by NASA's Hubble Space Telescope, along with observations from various observatories, have shown that scarab juice experienced a gigantic mass implantation in 2019. This event is rare for a star of its type and has incited the interest of stargazers. While coronal mass ejections are a regular event in our own sun, the special event found in bug juice adds a fascinating layer to how we interpret celestial life cycles and the dynamics of massive stars. The distance to dreadful Crawley juice remains a subject of discussion among stargazers. Some estimates propose it is farther away, while others suggest it may be as close as 724 light-years from Earth. Accurately determining the distances of red giant stars like bug juice is a confounding test due to their immense distances and extraordinary properties. Scarab juice stands out as one of the most brilliant stars visible in our night sky, displaying a brightness multiple times greater than that of the sun. However, this incomprehensible brightness comes at a massive cost. Bug juice burns through its nuclear fuel at an accelerated rate, racing towards the inevitable end of its glorious life. Eventually, the star will exhaust its fuel supply, inciting an emotional breakdown under its own gravitational pull, potentially resulting in an enormous blast impact that could give birth to a neutron star or even a black hole. Should our current astrophysical theories hold true, this raises a huge question. Does bug juice pose a risk to Earth? If a vast blast were to happen a few light-years from our planet, the results could be devastating. The impact of a supernova can release an unprecedented amount of light, potentially matching that of an entire galaxy. Therefore, whether or not scarab juice is somewhat distant, like the star Alpha Centauri, the effects of its immense blast could be huge and widespread. Remarkably, the last recorded supernova in our own universe occurred in 1604, and humanity still can't seem to locally observe such an event. However, an exceptional supernova did occur in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While that event had immense effects, it posed no impending threat to Earth, serving as a reminder of the scale and potential impact of such cosmic occurrences. The idea of a risk zone associated with a normal supernova is intriguing and could have serious repercussions for life on Earth if a supernova were to happen nearby. Ultimately, it's crucial to understand that, in the grand celestial timeline, supernovae are relatively small events compared to gamma-ray bursts, which are vastly more powerful and represent a different kind of threat. Gamma-ray bursts can have devastating effects capable of crushing biospheres and inundating planets with harmful radiation. For example, a specific type of astronomical burst could lead to the destruction of a planet's ozone layer, leaving it vulnerable to the harsh radiation of the universe long after the impact has occurred. This possibility was highlighted in a recent study that introduced new potential dangers connected with massive stars that end their lives in a spectacular fashion. When giant stars explode in a supernova, they can reach some of the brightest radiances known in the universe. In fact, the brilliance of a single supernova can surpass the combined brightness of millions of stars. This raises the question, what would the consequences be if frightening little creature juice were to undergo such an impact? If a supernova were to occur, frightening little creature juice would become the second most brilliant object in our sky after the sun. Shockingly, despite the distance separating it from us, dreadful little creature juice, which shines more brightly than a full moon, would become visible during daylight hours. The sheer power of the explosion would result in a display so dazzling that shadows would be cast even in complete darkness. Such a scene would both awe and astonish, demonstrating the raw power of cosmic events. While the visible light produced by a supernova is indeed enormous, it is only part of the total energy released during such an event. Although high levels of visible light can cause temporary blindness, the greater concern lies in the high-energy radiation produced alongside the visible light. This radiation often appears as X-rays and gamma rays, which can have wide-ranging effects. One of the most significant dangers posed by this high-energy radiation is its ability to catalyze the depletion of oxygen from the ozone layer, which shields our planet from harmful solar radiation. Without a healthy ozone layer, life on Earth's surface would be exposed to extreme ultraviolet radiation from the sun, potentially leading to mass extinction events. In the aftermath of a supernova, different risks arise over time. In the first minutes following the explosion, the intense radiation poses imminent threats. However, over time, massive light beams, particles pushed to near-light speeds, begin to travel through the solar system. These powerful beams can break apart ozone layers and blanket the Earth's surface with harmful radiation, worsening the dangers posed by the initial explosion. Moreover, supernova rays carry a significant portion of the total energy produced by the cosmic blast, and their long-term effects can persist for centuries. There is evidence suggesting that such events may have affected Earth in the past. For instance, elevated levels of iron-60, a radioactive isotope created in supernovae, have been found in ocean floor sediments and lunar regolith. This finding suggests that Earth may have been impacted by supernova ejecta in recent geological history, perhaps within the last few million years. Astronomers have already concluded that there are no nearby supernova candidates that pose an imminent risk to life on Earth based on our current understanding of the dangers associated with gamma rays and supernovae. However, ongoing research has uncovered additional potential risks connected with specific types of supernovae. These supernovae can release long-range lethal radiation that poses a greater threat to planets like ours. The mechanism behind this involves a star nearing the end of its life, surrounded by a massive disk of material. When the supernova occurs, a shock wave is created, striking this disk and causing it to become incredibly hot, thus producing a great deal of high-energy X-ray radiation that can travel vast distances through space. The most radiant X-ray cosmic explosions have the potential to deplete a planet's ozone layer by as much as half, creating conditions that could trigger an extinction event within a range of about 150 light-years. Fortunately, no candidate X-ray supernovae have been identified in Earth's immediate vicinity. However, this research has led to new insights into the concept of the habitable zone in space, the region within galaxies where conditions are favorable for life. The findings suggest that this habitable zone may be subject to additional constraints. Specifically, the outer regions of a galaxy may not have sufficient star formation activity to create the elements necessary for the development of rocky planets. Meanwhile, the inner regions, where stars form and die at a faster rate, present their own dangers. Constant supernovae in these areas can illuminate the surrounding space, increasing the risks for any potential life that could exist there. New research suggests that the inner boundary of the cosmic habitable zone is likely found farther from the galactic center than previously thought, reshaping our understanding of where life may potentially thrive. So, what would the frightening little creature juice supernova look like from Earth? While Earth's biosphere will likely remain unaffected, the actual spectacle will be hard to ignore. According to scientists, dreadful psi juice will continue to shine brightly for over 90 days following its explosion, reaching a brightness almost equal to about half of that of the moon on several occasions, and much fainter than a full moon. Essentially, it will appear as a bright point above, serving as a beacon that could be visible even during the day. Its striking brilliance will captivate anyone who gazes upon it, creating colored shadows in the evening. This celestial event will undoubtedly be a source of interest for everyone on Earth. As the cosmic explosion remains visible to the naked eye for months, its remnants will slowly fade as researchers continue to study bug juice. They are uncovering more about the life cycle of massive stars and the processes that lead to their dangerous endings. Understanding these vast phenomena is crucial for gaining insights into the evolution of our universe and the creation of elements during a supernova. Furthermore, the light generated during these events encompasses a wide range of heavy elements like gold, silver, and uranium, which are formed under the intense heat and pressure of the explosion. This process, known as nucleosynthesis, plays a key role in enriching the interstellar medium with the building blocks necessary for future star and planet formation. Interestingly, the remnants of a supernova, known as a supernova remnant, can turn into a stellar nursery where new stars are born from the dust and gas expelled during the explosion. This recurring process highlights the interconnectedness of galactic events and shows how the death of one star can lead to the birth of others. Scientists have identified several supernova remnants that are still forming new stars years after the original explosion, demonstrating the dynamic nature of the universe. Another fascinating aspect of studying supernovae is their role as cosmic distance markers. Astronomers use type Ia supernovae, impacts from white dwarf stars that reach a peak brightness, as standard candles for measuring distances in the universe.